All right, MMR and SD. A lot of today should be a review because you guys have all done mean, you've done median, you've done mode, you've done range. The only thing new really that I'm adding is standard deviation. And standard deviation is a little bit of a pain, but that's okay, we'll get through it. Okay, so, get a little light here. What I'm going to do is I'm going to give you one set of data, and we're going to work through all of those things on that one set of data. Okay? And it's not a very big set, but we're going to use 90, 93, 78, 88, 90, and 83. That's the set of data that we're going to find all of our calculations about. Okay? Questions there? How many numbers are on my list? 6. Okay? First thing we're going to talk about is the mean. What's the mean? It's the average, right? You add them all up and divide by however many there are. So we have the average. Add them all and divide by how many. So if I wanted to calculate the mean of this data, I would do 90 plus 93 plus 78 plus 88 plus 90 plus 83, and I would divide by what? 6. So go into my calculator. 90 plus 93 plus 78 plus 88 plus 90 plus 83, all divided by 6. 87. Is my mean always going to be a nice number? Not necessarily. It's a division problem, so you could totally get a decimal there. One thing that should be generally true is if your numbers look like they're all in the, let's see, the lowest one is 78, the highest one is 93, my mean better be between 78 and 93. Okay, that's something I do need to make sure. Questions about mean? There shouldn't be many because you guys have done this several times before, yeah? Median. Where have you heard the word median before? Where? When you're driving down the road, and if you're on the freeway, there's usually those cement barriers. But if you're on just, say, Foothill Boulevard, there's this nice little planter with some trees in it. And it goes down and it separates the cars going one way from the cars going the other way. That is called the median. Why is it called the median? Because it goes through the middle of the road. So the median has to do with what's in the middle. Now, we have to be specific when we're talking about what goes in the middle, because depending on what order you write your numbers in, you could have different numbers in the middle, right? If I wrote them in this order, then 78 and 88 are in the middle, right? So we have to have some standard way of doing that. So when we're finding the median, we have to have all the numbers in order, least to greatest. Okay? So I'm going to rewrite my numbers, all 6 numbers here, in order. Smallest one we know was 78. And then what? 83. And then 88. And then 90, 90, 93. Now, because I'm a perfectionist, I always go back and verify that I have all of the numbers written down, because inevitably I will make a stupid mistake and I will forget one number and it'll throw everything off. So I always verify 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. I have all 6 numbers. Okay, because if you miss a number, it really screws you up, unfortunately. So Now that I have them in order, I can identify what's in the middle. Now, unfortunately, because I have 6 numbers, there's not something directly in the middle. If I took off the 93, what would be in the middle here? 88. 88 would be my median. Okay? But if I have something like this, I have 2 numbers that are kind of shared in the middle. So, how do I find my median when I have 2 numbers in the middle? Well, you can think of it one of 2 ways. You can either take the average of those 2 numbers, which would be adding them together and dividing by 2, and the result should give you the number that is exactly halfway between those 2. If it's in the middle, it should be halfway between. So halfway between would be 89. Does 88 plus 90 divided by 2 give you 89? Divided by 2, yep. So my median is 89. So there is a chance that the median might actually be a number that's not on your list because it ends up falling between those 2 middle values. If it doesn't have 2 middle values and it only has 1 middle value, then that is your median. Capiche? We good? On to the next M. What's the next M? Mode. I think of mode as the most popular. I think of mean as the mean one because you actually have to do a calculation. Median, I think about the road because it's in the middle. And mode is the most popular. So what number on my list is the most popular number? 90. If I took off this first number and we were just looking here, what's now the most popular? None. They're all the same, aren't they? So in that case, we would say we have no mode. You can have no mode. No mode means nobody is more popular. Capiche? You can also have more than one mode. For example, if my list was, let's say, I'll write it in order here, 78, 83, 83, 88, 90, 90, 93. What's the mode there? 83 and 90 because they are both more popular than everybody else. So you can have more than one mode. You can have only one mode, or you could have no mode. Now here's a question. What if I added another 78, another 88, and another 93? Then we would have no mode because everybody occurs twice, nobody's more popular. Okay? As it is here though, whoops, that 78 is supposed to be on there regardless, it's still 88 and 90. Or 83 and 90. Okay? So? All right. Let's see. What's my next one? MMMR, range. Anyone know how you find the range? Yep. Now, the true mathematical way of that would be saying the greatest minus the least. But you take the biggest number on the list and you subtract the smallest number on the list. So I like going back to where it's all in order for my median because the biggest number's on the right, the smallest number's on the left. So 93 minus 78 is what? 93 minus 78 gives me 15. Now think about that for a minute. What does the range tell us? If my range is 15, whereas on another set of data, what if my range was 30? What would that tell me about the data? About the numbers on my list? They're farther apart. Okay, so it can kind of tell me how much spread there is in my data or if they're all more kind of compacted and everything's kind of around the same. Okay? All right, mean, median, mode, range. And the last thing we have to do is the standard deviation, which is a little bit of a pain in the tush, but we'll get through it. Standard deviation is the most involved calculation of all of these. You are absolutely going to need your calculator. So, I should go back for a minute and just give you a little bit of notation. Mean, median, mode. Mean actually has a symbol to represent it. If you see this symbol right here, X bar, that means mean. So if it says find X bar, they're asking you to find the mean. It also could be notated as this funny looking U. It's like a U with a tail on the front. Anyone know what that is? It's a Greek letter mu. Okay? Both of those mean. They're not big difference. The main difference is if you are finding the mean of a sample, you use the X bar. If you are finding the mean of a whole population, you use the mu thing. Okay? Does that kind of make sense? And there's this whole, like, nasty, ugly formula for it. Do you see this thing right here? That's the mathematical way of saying add them all up and divide by how many there are. Okay, so sorry I didn't make you write that one down. Yeah. Okay, standard deviation. Again, a little bit of a pain in the butt. It is a measure of the variability of a sample from a larger set of data. Now, I'm not so concerned that you fully understand the definition of that right now, but the way of calculating it is the important part. When you get to your stats class, that's when you'll really interpret standard deviation a lot. And we'll see this more as we move into Mod 21, because the standard deviation is used hugely on something called the normal curve, which is what all of Mod 21 is about. Okay, also known as the bell curve, if you've ever heard of that. Okay, so here's how you find your standard deviation. First thing I'm going to do, I'm going to write down all my numbers right here. Totally does not matter if you write them down in order or not, but I'm going to give each number a line. Okay, so let's see. I have 90, and then 93, 78, 88, 90, and 83. So far, so good? Yeah? From each of these, I'm going to subtract the mean. What was the mean? 87. So each of these, I'm going to do minus 87. So 90 minus 87 is 3. 93 minus 87 is 6. 78 minus 87 is negative 9. 88 minus 87 is 1. 90 minus 87 is 3. And 83 minus 87 is negative 4. So far, so good? It's not a difficult process as long as you kind of keep it organized. Next step, I am going to square it. So each of these results, I'm going to square. So I get 9, 36, 81, 1, 9, and 16. So far, so good? Add them all up. So let's see. 9 plus 36 plus 81 plus 1 plus 9 plus 16, 152. Now, 152 is not my standard deviation. I have to do one more thing to that number. Well, technically two things, I guess. To find a sample standard deviation, I take that 152, I divide it by n minus 1. What do you think n is? 6 minus 1, because there were 6 numbers on my list, and I take the square root of it. So in other words, the square root of 152 divided by 5. And I get 5.5. That's my standard deviation. So let me refresh that. We took our numbers, subtracted the mean, which we already had calculated, right? Squared the results, and then added them all together. Then we divide by n minus 1 and square root it, and that's our standard deviation. Okay? It's not a difficult process, but it's a little bit more of a pain than just, say, calculating the mode, because that's super easy, right? Now, there is one major difference. If you are looking for the standard deviation from a whole population, the only difference is you still get your 152. You don't divide by 6 minus 1. You just divide by 6 instead of subtracting 1 from it. Don't ask me why it's different. Ask your stats teacher when you get to that class. But if for some reason it says the standard deviation of the entire population, that's what you would do. And it's slightly different. In this case, it's 5.03. We'll say 5.0. Okay. Now, just like up here, how I had some notation things that I needed to show you, these have notation also. A sample standard deviation is notated by the letter S, a lowercase s. Of a population, it's a funky O with like a hat on. Does anyone know what that is? It's a Greek letter. It's a Greek sigma. Didn't we see sigma when we were doing sequences and series? But it was that big E thing. That's a capital sigma. This is a lowercase sigma. And that is your population standard deviation. Now, all of your homework is going to be a sample standard deviation. Okay? This is just thrown in there just so you know what it is. And unless the problem says it's a whole population, assume it's a sample. Okay? So unless it says this is your whole population, stick with the sample formula, just doing the n minus 1. Okay? Any questions there? All right. I did post your homework. This is all the stuff you're going to be asked about. Happy studying.